Okay, I'm going to try to do this problem with the calculator that's there, as well as setting this up. We're looking at a two-sided proportion test, and there were 401 successes out of 667 samples. So our p hat is equal to, that comes out to be, I did this earlier on the calculator, 0.601, oops, sloppy, sorry, 0.601, okay? So that's our p hat value. Now, that's actually less than the 0.66, which means we could also have done an alternate hypothesis of less than there. Okay, but it was a two-sided test. We don't get to decide which way. It depends on the language, and the person asking the question gets to make that decision. So this was something, is there evidence that it's different than, or something to that effect? And there is certainly some evidence that it's not 0.66, since our p hat did not come out to be 0.66. But could this have happened by chance, even though it is 0.66? Yeah, definitely could. And how likely is that to have happened? That's what we mean by the p-value. It's a two-sided test, so we're going to go 2 times the appropriate one-sided test. Well, what's the appropriate one-sided test? Well, remember the p-value is the probability of getting our sample result or something which is better evidence. Our sample result was 0.601. Better evidence for the appropriate one-sided test would be less than, since the 0.601 is less than 0.66. So now I'm going to ignore, because I want to try to make this short and get it posted, checking the conditions: simple random sample, sample size not too big relative to the population size, and n times p, and n times 1 minus p being bigger than 10 with an n this big. Those are going to both be true. So it's approximately normal, so we can use our z-score formula, which is p hat minus p over the square root of p times 1 minus p over n. And we're going to go 2 times the probability that z is less than or equal to 0.601 minus 0.66. That's our p hat is 601. Our p up here is 0.66 over the square root of 0.66, 0.34 over 667. Okay. We could, at this point, choose to go to the tests menu to figure out what that value is. I'm okay with that once you've got it set up and it's clear what formula you're using and what the numbers are that you're plugging into that formula. You can use the calculator to do the actual calculations. And it turns out that if you do all of that, I'm going to come over here and turn on my calculator, go second, oops, I don't have to go second, sorry, go into stat and over to tests, and this is a one proportion z test, so I'm going to hit 5 there, and you can see I've already put in the values: 0.66 for my hypothesized proportion, 401, 677, and they're not equal to. And I'll go ahead and do this. Get down to calculate. And the z turns out to be less than or equal to negative 3.21 would be okay there, 206, wherever you want to round that off. Okay. Now, I would also be okay at this point if you just said that's equal to the p-value of 0.001, but I want to talk about doing it not using the test menu. If you calculate this big thing, it might not come out to be exactly the same as that because of the rounding with the 601. I guess that's the only rounding in there, so if you use more digits than 601, you would get closer to this answer than you might with just 0.601. And then the z less than or equal to negative 3.2, that's a normal distribution. Negative 3 is here. We want that area out there, so it's the normal CDF from negative 99 up to, over a little bit, I'm just going to go off the screen, negative 3.206. Okay. And then that value, whatever that comes out to be when we multiply it by 2, is going to be in the neighborhood of 0.001, which is what it shows on the calculator over here as the p-value. Let's go ahead and do second DISTR and go to normal CDF, which is 2, and put in negative 99, comma, negative 3.206. And hit enter there. It goes into scientific notation, and I'm going to multiply that by 2. Getting the wrong side of my, there we go, times 2. And it comes out to be, like we said, about 0.001 once we multiply that by 2. So either way, the test statistic, I got lucky over here. The test statistic, I did happen to round off to 3 decimal places without actually reading that there. And then the p-value, it says to 4 places, so I should have a 3 on there from the calculator there. That p-value, let's see, how does it compare to alpha? Alpha is 0.001, so this is actually bigger than alpha, greater than alpha, which means we are going to fail to reject the null hypothesis and say there is not sufficient evidence there's 2, there is not sufficient evidences here. Better be careful. There's not sufficient evidence to warrant the rejection of the claim that it's not equal to. Okay, and that's a double negative in there. I have to read that carefully. No, the one that there's not sufficient evidence to reject is the null hypothesis. There's not enough evidence to reject that. I've made a mess of that. There's not enough evidence to conclude that one, and so there's not enough evidence to support the claim that it's not. Okay, so that's that, and that one is the answer there. Okay. Hope that helped some.